Hi everyone, Francis is here. In this lesson, we'll be discussing rational zero theorem. First, what is rational zero theorem? This theorem helps us to list all the possible rational zeros of a polynomial. To start with, let's take an example. Given or rather, if I say given f of x equals to x raised to power 3 minus plus 2x raised to power 2 minus 5x minus 6. Given this, find the zeros. Find the zeros, meaning of this function. So what do we do? To find the zeros of this function. In fact, to find the zeros of this function, I simply, as you know, finding the zeros of this function is similar to saying find the solution of this polynomial. It's also the same as saying find the f of x that equals the f of x or the x such that when I put it into this function, it gives me 0. I get 0. So to do that, we simply divide. What we need to do is, the step is to divide this polynomial with the coefficient of the leading term. And what's the leading term here? It's x raised to power 3. X raised to power 2 follows, and x raised to power 3, and then this constant. So in their order, this is the leading term. And what's the coefficient of this leading term? It's -1. So to get the x such that when I put it into this value here, when I put it into the f of x here, to do that, I need to divide the leading term with the last term. Not just the leading term with the last term, but the factors. I would list the factors of the last term. Okay, let's put it this way. To get the rational, let's just put it this way. Associate this associate this last term to b, say b, and associate this the coefficient of the leading term here to b, and which is 1 to be a. So how do I get the rational zeros? Or first, how do I get the rational zeros of this function? What I need to do is the value that would give me, that when I put into this x that will give me 0, will lie in between, will be factors of this last constant divided by the coefficient, factors of this coefficient here. So let's see. So b over a. What are the factors of minus this b, or minus 6, which I've associated with b? What are the factors of minus 6? So I will list them here at the top here. It is plus or minus 1, plus or minus 2 is a factor of this, plus or minus 3 is a factor of 6, and then plus or minus 6 itself is also a factor of 6. And when I'm talking about factors, I'm talking about whole numbers, integers. I'm talking about integer values of -6 that would give me integer values of integer factors of -6. So, and these are all the integer values of -6. We'll do the same thing to So what are the factors of minus 1? I've associated that minus 1 to a. What are the factors of this minus 1? It is only plus or minus 1. Now, this set, what I have here now is a set of all possible values. Is a set of all possible rational zeros of this function. Is a set, I'll repeat, is a set of all possible rationals of this function. Meaning that a combination of the numerator and the denominator, a combination of this within any of these values is a value that would give me, that will make this f of x to be equals to 0. So let's proceed. So in other words, our b over a, the only values when I combine this over this would be when I divide the numerator with the denominator, divide the numerator, every of this numerator with the denominator, what I will still get to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So this from here now, I could keep testing values to see which gives me 0. And when I find the one that gives me 0, I've found one of the zeros of this function. To now find other zeros of this function, I could simply bring x. Let's proceed and see what would. Simply make x to become a factor of this and then divide using synthetic polynomial to divide this, or long division polynomial we had done earlier. So let's proceed so you see what I'm saying. Now let's try 1 plus 1 here and put it into this value. See if f of x is equal to this. So let's try plus 1. I'll simply say f of 1 will be 1 raised to power 3 plus 2 into brackets 1 minus 5 into brackets 1 minus 6. If I evaluate this, I'll have 1, 2, minus 5, and then minus 6. 3 minus 11. That's 3 minus 11, that's minus 8. 1 plus 1 is 3. And minus 11 minus 11 minus 5, this is minus 11, and the sum of that gives us minus 8. So this is not a 0 of this function. F of 1 is not a 0 of this function. Let's try another value. F of 2. We'll have 2 raised to power 3 plus 2 into bracket 2 raised to the power 2. This should be raised to power, this is also raised to power 2. Minus f5 minus 5 into bracket 2 minus 6. We'll have 8 plus 8 minus 10 minus 6. So this plus this is 16. This plus this is 16. Minus 6 minus this is minus 1, 6, which is equal to 0. So therefore, f of 2 is a 0. Haven't gotten 0 here. That says that f of 2 is a zeros of this function, or 2 is a zeros of this function. So what do we do from here? Recall, since x is a zeros of this function, we've gotten one of the zeros. How do we get the two other ones? Keep in mind that whatever powers of highest powers, the highest powers of polynomials you have here, if it is 3, then it means we're going to have 3 zeros of a function. 3 solutions. 3 values of x. So we've gotten the first one. How do we get the other two? We simply use make x, see x, bring my plus 2 into this side of the equation. It becomes x minus 2. What do we do to get the other two zeros of this function. We'll divide this function now with x minus 2. For x minus 2 is one of the factors of this, so we divide this function, this f of x, with x minus 2. We can either do that using the long division method we discussed earlier on, or we use the synthetic method. So that will be all for now. In the next lesson, we'll continue from here and get do the long division method or the synthetic method to get the two other zeros of this function. See you in the next lecture. Bye for now.